Hello students, welcome back to Organic Chemistry. In today's video, I'm going to explain how to name the organic molecules with more than one functional group. That means what? We are going to name bifunctional and polyfunctional group molecules. This is one of the important topics in organic chemistry and many students have problem with this particular topic. So let's deep dive in this topic. Whenever we have organic molecules, the molecules may not have functional group, like in this case, it's just a pentane molecule, or it can have one functional group, for example, alcohol, or it can have two functional groups, say for example, a ketone and a hydroxy group or an alcohol group, or it can have more than two functional group, for example, there is a ketone and then there is a halogen and then there is a OH group. So far we have seen how to name alkanes and molecules with one functional group. In today's video, let's see how to name such bifunctional or polyfunctional group molecules. For these molecules, students always remember there will be always a principal functional group. Principal functional group. What is principal functional group? The one which will have higher priority in the order. That means what? There is a order for different functional group. I'm going to give that order very soon. First understand the principal functional group will always get a priority and it is always written as a suffix. What does that mean? See, for this molecule, there is only one functional group. Therefore, you are going to call this as pentan to all. All is the suffix for an alcohol. But because there are two functional group here and this becomes the principal functional group, right? The name of this molecule should end as on but not as a alcohol. So the principal functional group is the one which decides the suffix. Then what about the OH? How we should represent it as? We have to represent it as a prefix because it is a secondary functional group or a subordinate functional group which will be always a prefix. You have seen here the OH is written as all. Now we can't use the all. Now it will have a different name. It is called as hydroxy. That means what? This will act as a prefix and this will act as a suffix. What if there are more such secondary functional group? Very simple. You have to give the priority according to their alphabets. That means what? Here it is a chloro, here it is hydroxy. That means what? The chloro must be written first because of the alphabetical priority. So students, remember, the principal functional group is the one which will decide what must be the suffix, and secondary group must be written as a prefix, and if there are multiple, always arrange them according to the alphabetical priority. Whenever you look at the molecules with more functional groups, always first try to identify what are the functional groups given in the molecule. For example, the molecule shown here, the first molecule, you see that this is a ketone and this is an aldehyde. Why so? Because you see the carbonyl is attached to hydrogen. That's why. Then what you have to do is look at the order of different functional groups here. You see acid at the first and then sulfonic acid, ester, acid chloride, amide, nitride, aldehyde, ketone, alcohol, amine, then a double bond and then at the end triple bond. This is the order of priority for the different functional groups what I was telling earlier. Since you have identified the functional groups, check where is the aldehyde and ketone. So aldehyde is having more priority than the ketone because it is written first. That means what? This will become a suffix and this will become a prefix. Similarly, what we have here, ketone, and what about here, a carboxylic acid. Carboxylic acid is always at the end. This you have to remember. This is very important. So this is suffix, and what about this? This is a prefix. Similarly, cyanide. What is cyanide here? It's a nitrile, right? And what about the OH? You see, it is after the cyanide. That means what? This will become suffix and this will become the prefix. This is the first thing you are going to do. Look at the different functional groups and then try to memorize or try to remember where these functional groups are placed, and then decide which is suffix and then which is prefix. Now, how to name these prefixes? Should I still call it as on or keto or oxo, right? We don't know that. For OH, how to call this? Is it still alcohol or hydroxy? So for this, we need to remember what these functional groups are also named as prefixes. So let's go through that table. If you want to excel in organic chemistry, then this table is very important for you. You have to memorize this table in order to get the correct names of the organic molecules. But don't worry, this is not so difficult. I'm going to make it simple for you. How? See, certain molecules, what I have given here, they are going to have only suffix like alkane, alkene, and alkyne. Certain molecules are going to have only the prefix, like for example, halo, and even the ethers like alkoxy, right? And nitro. So these are going to be only the prefix. What about the other molecules? For them, you have to remember how to name them as a prefix and a suffix. For example, the OH as a prefix is hydroxy, as a suffix, it's always all, right? So this way, you have to remember the prefix and suffix of the functional groups and try to name as many molecules as possible so that you will get a hold of naming the molecules. So let's get started with naming the molecules with bifunctional and polyfunctional. First, let's start with the bifunctional groups. You see, this is an aldehyde and alcohol. Aldehyde will get the priority. Therefore, the suffix should be al. And the numbering must be from the functional group carbon, as the functional group carries the carbon. That's why. Now, at third position, you have OH. Therefore, 3-hydroxy. There are 4 carbons. Therefore, butane, 1-al, or 1-butanol, or simply butanol will also do. Now, for carboxylic acid and halogen, the carboxylic acid will get the priority. That is the topmost, right? So, therefore, butanoic acid should be the root word and the suffix. Then what should be the prefix now? 3-chloro butanoic acid. Butanoic acid, or 1-butanoic acid, or butan 1-oic acid, either way. Now, here ketone is the principal functional group. You should not start numbering from here. You should start from here. Okay. And if we start from here, the amino group will get the amino carbon will get the second number. But that's not our priority. The priority is principal functional group. Therefore, 4-amino. That means what? As a prefix, the NH3 is called as amino. That you can refer from the chart. Initially, you can always refer to the table. So once you get used to the prefix and suffix, you can start naming the molecules on your own. So 4-amino and pentan 2-on. Pentan 2-on. It's better to write the position of the ketone because it can be even 3-on. That's the reason. Okay. So anyway, moving on to the next molecule. You see here, I'm taking an alkene and acid, and both are always suffix, right? So in this case, what you have to do? Generally, we call this as butanoic acid, but instead of butane, you have to call this as butene, right? But which will get priority? Always carboxylic acid, as it is a principal functional group. That means what? You can call this as but 2-ene 1-oic acid. So that means what? It's basically butenoic acid. Many students miss out this alkene part, so please remember it's a butenoic acid. Similarly, for this molecule also, the principal functional group is ketone, right? So generally we call this as pentanone, right? So instead of pentan, we have to call this as pentene. So how are we going to name this? Pent 3-ene 2-one. 2-one. So it's a pentanone molecule. Now, when we have an alcohol and a double bond like this, in that case, the priority while numbering is always should go to the oxygen attached carbon. That means OH attached carbon. And we call it as hexanol, but since there is a double bond, call it as hexenol, right? So in that case, how are you going to name this? Hex. At what position we have the double bond? Third, right? 3-ene and 2-ol, hexenol. Enol is the suffix for the molecule. For the given polyfunctional groups, always identify the principal functional group and secondary functional groups. Here we have carboxylic acid as a principal functional group. The rest groups are going to be the prefixes, whatever are the groups here. So there is a chlorine and methyl. So arrange them according to the alphabetical priority. So 2-chloro, 3-methyl. Altogether, there are 4 carbons here, right? Therefore, it's going to be butanoic acid. Butanoic acid. For the next molecule, identify the principal functional group and it is an amide. Many students make a mistake of calling this as diamino because there is NH2 and NH2 and they'll call this as ketone for some strange reason. But students remember whenever there is CO attached to NH2, it's an amide. Identify that first. So the prefixes are going to be amino and bromo. And what about the suffix? It's going to be amide because we have a amide functional group. So bromo and amino, arrange them according to alphabetical. So 5-amino, 2-bromo, 6 carbons are there. Therefore, hexanamide or 1-hexanamide. If numbering is not given, that means what? By default, it's going to be at the first position. So hexanamide. Now, again, same here also. Don't take it as a dichloro because COCl itself is a functional group. It's an acid chloride. Therefore, the name should end as oil chloride. And this is a principal functional group and these are going to be the prefix. So, how we are going to call this? 5-chloro 2-methyl hexanoyl chloride. Hexanoyl chloride. Like this. Now, this is a tricky one. So, try to understand this carefully. Whenever we have an ester, always choose the longest chain from the CO carbon. And then, this is always an alkyl group. We have to name this as alkyl and at the first of the name, irrespective of the order of priority when it comes to the prefixes. Okay. What I meant is first you name this as ethyl. And then you have to give a space here. It's not complete name, unlike the first 3 molecules. First you write ethyl, right? Give some space and then there is a chloro and nitro as prefix. So 4-chloro and then 5-nitro. The 6 carbons, therefore hexane O8. Hexane O8. This O8 and this ethyl, that shows that the functional group present in the molecule is an ester molecule. Now, I'm going to name some of the cyclic molecules with more than one functional group. Whenever we have cyclic molecules, numbering the carbons in the cyclic chain is important. Here, I have taken cyclohexane molecules, but you can try with cyclobutane, cyclopentane molecules as well. Since ketone is a part of the cyclic chain, we number the carbon of the cyclic chain first. Since it is a principal functional group, we call this as suffix and OH will become the prefix. So that means what? It's going to be 2-hydroxy. Don't forget the prefix cyclo, right? Cyclohexane 1-one or 1-cyclohexanone or simply cyclohexanone. For the second molecule, first see here which is the principal functional group. CHO is the functional group. That means what? The overall molecule must be named as cyclohexane carbaldehyde. Then what about the numbering? Should you start numbering from this carbon? No. We always number only the carbons of the cyclic ring. But the priority goes to the carbon where the functional group is attached. That means what? The name of the molecule is 3-chloro, right? And then cyclohexane carbaldehyde. Carbaldehyde. If it is a 5-membered ring, call it as cyclopentane carbaldehyde. Okay. Now, this is a tricky molecule wherein there is a double bond within the molecule. In that case, no problem. You number the cyclic chain and make sure that the functional group attached carbon will get the top priority and then the double bond. So generally we call this as cyclohexane carboxylic acid, but now it will become cyclohexene. So which cyclohexene? See here, cyclohex 2-ene and 1-carboxylic acid. Right? Next, we have 3 functional groups, but the rules are going to be same. That means what? Number the chain, cyclic chain, and then alphabetical priority for the prefixes. So we have chloro and nitro. Therefore, 3-chloro, 4-nitro, then cyclohexane carbaldehyde. Aldehyde it is, so carbaldehyde. So this is how we name the cyclic molecules with more than one functional group. Let's see some aromatic molecules with more than one functional group. For aromatic molecules, we have a different kind of prefix. These are commonly used in the trivial names. It's called as ortho, meta, and para. Ortho positions are the one which are next to the ipso carbon. So let's assume there is a substituent that attached carbon is called as ipso carbon. Next to that we have ortho, next to that is meta, and then we have one para position. In the first case, since there are 2 methyl, you can call this as ortho dimethyl benzene, or this is also known as orthoxylene. We can also number it. How? Like this. Therefore, you can also call this as 1,2 dimethyl benzene. Let me repeat this. 1,2 dimethyl benzene. That is the IUPAC name of the orthoxylene molecule. If the methyl is here, metaxylene. If it is here, paraxylene. So xylene is basically dimethyl benzene. For the next molecule, you see COOH is the principal functional group. Therefore, this is the ipsocarbon. Then this will become metahydroxybenzoic acid. Or if you want to number it, number from here. So 3-hydroxybenzoic acid. Next, we have OH and chlorine. Generally, the OH is called as hydroxy, but when hydroxy is attached to benzene, we call this as phenol. That means what? This is a parachlorophenol or 4-chlorophenol. How do you know it is phenol? Because the OH attached benzene is always known as phenol, not the hydroxybenzene. That I have taught in the previous video. Here we have methyl attached to the benzene. Then we call this as toluene. So common name of this would be parafluorotoluene or 4-fluorotoluene. Similarly, here we have to number it like this. 1, 2, 3. Many students, what they do is 1, 2, 3, 4, 5. This way they do it. No, that is not correct. Therefore, it's going to be 3-fluoroacetophenone or metafluoroacetophenone. Similarly, here also you see it is at the third position. Therefore, 3-nitrobenzoyl chloride. Next, at ortho position there is a chloro. Therefore, orthochlorobenzaldehyde or 2-chlorobenzaldehyde. For the last molecule, you can try naming this molecule, and if you want to verify the answer, comment it in the comment section. Thank you for watching this video.